This is the topic where basic principle and mechanism of EOR, of course IOR included, will be explained. First, I will explain what is the principle, basic idea, and then I will explain little about the mechanism involved in the EOR processes. To understand the principle, I have bring about dictionary meaning from two different sources. First from the Google, also it takes from the different dictionaries, and second is from Cambridge University. What does principle mean? Actually, the fundamental truth that actually serves as a foundation for the system. And of course, there is another meaning is called scientific theorem or law, like Archimedes principle or Graham's law, or different principles are there which explains actually the scientific theorem or law involved in it. In the different second, the basic idea that's actually explain or controls how something happens or work. So when I come to the principal part for the EOR, it will be like fundamental truth. This is a truth that is very fundamental, and that fundamental truth will build the foundation of the system, foundation of the EOR. To understand what is the foundation of the EOR, let us move forward. We understand that when a field is discovered, it undergoes particularly three stages of production: primary, secondary, and tertiary. In primary recovery, a well is drilled, and drilling depletes the pressure, and that depletes in the pressure actuates the compressibility of the rock and fluid, particularly for the fluid, and thus production happens. That we call natural energy. And that natural energy comes from the compressibility of the fluid. Compressibility of the fluid, particularly from the fluid like oil or gas or water, mainly from this. And second is water or gas injection or water flooding. Third is called EOR, tertiary recovery, enhanced recovery or tertiary recovery. Here what we do, if natural energy is available, or we keep on injecting water, but instead apart from it we inject something which changes the rock and fluid property. What is actually EOR is changes the rock and fluid property. What is this rock and fluid property? I will explain in the later video. But EOR is nothing but the changing of the rock and fluid property with extraneous fluid. What could be this extraneous fluid? Like we inject ASP, alkaline surfactant polymer, we inject CH4 for the miscible, we inject C2, C3, we inject CO2, we inject nitrogen. So these extraneous fluid, when go inside the reservoir, it changes the rock and fluid properties, and these changes in the rock and fluid properties helps mobilizing the reservoir. But we understand that when a field is discovered, there is an initial oil saturation called SOI. When we do water flooding or simply water and gas injection, in today, industry concept are There is no single boundary or say thin layer boundary between water injection and water flooding. Even when we do water injection, there is a water flooding, but not in a pattern wise. Well, pattern is not fixed, but in water flooding, well pattern is very important. In the secondary recovery, when we do water flooding, this SOI is reduced to SOR value, and that SOR, and based on this recovery factor, if you calculate is, there is approximately 37% worldwide. So the remaining oil which left after secondary recovery demands a different kind of process that we call EOR, and where we can further reduce to a different level. Like here the SOI is 60%, SOI is 60%, and this reduced to say 45%, and further if we could reduce even 5%, that would be a very big achievement when it comes from the EOR. That actually not 5%, in somewhere it is almost 30-40%, but approximately say 5%, 1 to 3% is a good amount. Now what we are understanding here in different recovery processes, that is primary, secondary recovery, what we are trying to understand is the reduction in the oil saturation. The foundation or the principle of EOR is the principle of EOR will be the reduction in SOR value. And when there is a reduction in SOR value, there will be a improvement in the recovery factor. And when there is improvement in the recovery factor, there will be a profit. And that is where every oil company is interested in. So we understand that the principle of EOR is the reduction of SOR value to a different lower oil saturation, and thus improving the recovery factor. This reduction in the SOR depends on number of factors that will be discussed later. But what we need to understand is there is a push, pull, and somewhere in between, push, pull, plus some addition. That when in the primary recovery well was injected, when well was injected, there was no driving force. There was a depression drive, but not like water kind of a depression drive case. When well was drilled and it did some production of oil, and that actually reduction in pressure that actuates the compressor that I explained earlier, that creates the delta P in the reservoir and the sand phase, and that is actually pulling the oil from the reservoir. So here what we call it, the primary recovery. Push is something injection from the behind, from injection well, and driving that oil from the reservoir to the production well. Here we call it secondary recovery. And in addition, the EOR is there, which works in between these injection and production well. So when it call it EOR, this will work actually in between, that means in situ condition inside the reservoir, where the porous media where oil is actually trapped. When you call it trapped, it's actually in the smaller pores where it can't move by itself. Even we apply some push. So what we do, we add some chemicals, or we do some mass transfer, dissolving a lighter component of hydrocarbon or CO2 or nitrogen. That actually helps mobilizing it. So when it comes to mobilizing it, or whenever that mobilization is there, there will be a reduction in the SOR value. So every idea or every process, every methodology that we explain in EOR is nothing but the reduction in the SOR value, and mechanism or process will be revolved around it. So when it comes to second part, that is mechanism, we explain the principle first and second is mechanism. There are basically four methods or process of EOR. It's called chemical method, second is miscible, third is thermal, and fourth is microwave. There are other methods which is evolving as a combination of these two. These any kind of method. There are subsection as well, subtopic as well. This is called hybrid type. Today there is an evolving phase, and industry is applying this somewhere. I will talk it in later. But chemical is, it's called ASP, alkaline surfactant and polymer. What polymer does, it increases the water viscosity when it dissolves into the water. It increases the water viscosity, and it reduces the KRW, water relative permeability of water. Everything that we wanted is not producing water from the reservoir. So reducing the relative permeability of water is the major idea. We understand the mobility, that is mobility is equal to K by mu. If you call it water, it will be like KRW by mu water. If the denominator is increasing and numerator is decreasing, that mobility will also decrease in another extent. And that's what we wanted. Reducing the mobility of water and increasing the mobility of oil. What surfactant does, it reduces the interfacial tension between oil and water. What interfacial tension is just the less will be the, in simple term, when I call it, it's a simple term, 1L, like interfacial tension oil water 1 is less than interfacial tension oil water 2. These will require less energy to mobilize the oil compared to the surface tension, interfacial tension oil water 2 system 2. So reduction in, when there is a reduction in surface tension, it is actually helping. It is like one is attached to something. Reduction in surface tension is like that attachment to something is reduced. That will also increase the oil mobility and reduction in the SOR value. What does alkaline does? It reacts with the heavy components of oil or resinile components of oil and creates a in situ surfactant. What it does, it creates a in situ surfactant, and when surfactant is created, thus it acts like a surfactant as natural. It reduces the oil water surface tension, as well as it reverse or try to modify the wettability of the system. When oil weight is there, it converts into the water weight. I'm talking in a layman term. I will go into the each and every topic in a later and dive deep into that topic. In miscible, what it does in a layman term, what we can understood is it try to bring the surface tension close to zero. In surface tension, today it reaches less than 10 to the power minus 3 dyne per centimeter. This is called ultra low surface tension. But in miscible condition, when it tried to actually reach the surface tension close to zero. And when surface tension close to zero, the capillary number reaches to infinity. And that is the case when it is for oil, it is like highway. They are running on the highway. and that zero surface tension between oil and water is achieved through called basic idea is mass transfer. Latter component of like CH4 lean gas CH4 is injected, which combine with the oil, and combine means there is a mass transfer of the component from CH4 to oil, and when there is a latter component dissolving into the heavier component, the overall effect will be like reducing the viscosity, density, and reaching a state where that surface tension is almost zero. And that could be achieved with different method like CO2 injection. At higher pressure, CO2 acts like a miscible. In like CH4 is injected, enriched gas is injected like C2, C3, C4, or some other like nitrogen is injected. These chemicals are not these agents actually try to reduce the surface tension to such an extent it's like no attachment with the rock layer and the oil, and oil mobilize as free as possible. Here in EOR purpose you get the highest or the lowest highest recovery factor and the lowest SOR value. In thermal method, what we do, we reduce the oil viscosity, major part, and this type of mechanism is applied. This kind of process is applied where oil is mostly heavy kind of in the range of less than 20 API or less than 15 API, where oil is almost not mobilizing. Its affinity with the rock is very high. Even in the high permeability zone, it can't move as its own due to natural energy or even water injection. So when temperature is increasing, that viscosity of oil will be decreasing, and there is a very little effect of temperature on the water. So when I explained you earlier the concept of mobility, that is the mobility of water, mobility of oil, mobility of displacing fluid by mobility of displaced fluid, and that is actually KRW by mu W and KRO by mu O.
Here in microbial, it's a use of biotechnology for the purpose of EOR. Instead of like chemical, when microbes are injected, microbes, it's called nano microbes. When injected, it generates in situ surfactant, or it generates the nanofilms, biofilms, or it generates the alkaline. But when it generates alkaline or nanofilms or biofilms, it reduces the surface tension and it acts as like alkaline is injected. But everything is like generating the macros, injecting or activating it in situ in the reservoir, the different methodology or different process. When it comes to hybrid, it is the combination of different EOR processes which generally known. Today it is applied in many fields where most of the mechanisms are combined together to get the more efficient and more recovery factor. But what we can see that thermal and non-thermal, there are different EOR methods or processes where hybrid system is applied. Like we know the steam assisted gravity drainage or air assisted gravity drainage, like in situ combustion. Steam assisted gravity drainage is a combination of horizontal well and water flooding and steam flooding. And it's called air assisted gravity drainage, or solvent assisted gravity drainage. It's a combination of chemical and thermal part. There are like air assisted gravity drainage, say air injection like miscible and the effect of gravity and steam injection. So it's always a combination of one or two methods altogether to first to achieve the efficiency, and second to achieve the high recovery factor. And today these two factors control the application of EOR. These hybrid methods actually control actually in a different situation combination of could be applied. ASP is one kind of hybrid approach where alkaline surfactant and polymer are all together is applied. Or after polymer the steam is injected, or in between some polymers are injected, but polymer has a limitation of high temperature, so mostly polymers are not used with the thermal methods. In mechanism part, I have taken only the overall idea, but deep inside you will see more process, and that actually revolves around these ideas. Hope you have learned something. Keep watching GATEbandhu. Thank you.